everyone. I am Dr. Anubha Gupta, Assistant Professor in the Department of Applied Science in ABES Engineering College. Today I am going to discuss relation for relative refractive index and V number with numerical aperture in optical fiber. These are the content of my lecture. Definition of numerical aperture in optical fiber, then relation between relative refractive index difference and numerical aperture, relation between V number and numerical aperture. After that, we will discuss numerical based on the above topic which we discussed. So what is a numerical aperture? Numerical aperture is the number, is a mathematical quantity which is a unitless, and it only shows the light gathering capacity of the optical fiber. How much light can be gathered by the optical fiber? So numerical aperture shows light gathering capacity of optical fiber is known as numerical aperture. Numerical aperture, the abbreviation for the numerical aperture, we will use NA. So mathematically, numerical aperture is a square root of refractive index of the core and the refractive index of the cladding. Basically, we know that if we go to the basics of optical fiber, we know that the optical fiber are the concentric, coaxial, cylindrical in a shape, and the inner cylinder is called the core and the outer cylinder is called the cladding. Inner cylinder has a refractive index N1 and the outer cylinder has a refractive index N2. If the light is incident on the optical fiber, then light will undergo TIR inside the core and information will be carried out from one point to another point. This angle can be vary from the 0 degree to the maximum value. The maximum entrance angle is called the acceptance angle. This is the acceptance angle. So if suppose it is a alpha max, which is the maximum angle at which the light is launched at this end and it will do TIR inside the core, then second definition of the optical of the numerical aperture is numerical aperture is also defined as the sign of maximum acceptance angle. This is the sign of maximum acceptance angle. It's also called as numerical aperture. Because we already discussed that alpha max is the sine inverse N1 square minus N2 square. This is the alpha max. So sine alpha max, which is the N1 square minus N2 square, it is equal to numerical aperture. So I will write all the formula again. The numerical aperture is defined as N1 square minus N2 square, where N1 is the refractive index of the core and N2 is the refractive index of the cladding. And we know for the TIR, N1 is always greater than to the N2. And alpha max is the acceptance angle, which is equal to sine inverse of N1 square minus N2 square. And the another definition of the numerical aperture is the sine of alpha max, maximum acceptance angle. So these are the basic formula which we use to calculate the numerical aperture. Now we will discuss the relative refractive index and numerical aperture relation. First of all, we will discuss what is the relative refractive index. Relative refractive index is symbolized as delta. It is the ratio of difference in the core refractive index to the cladding refractive index divided by the core refractive index. This is the relative refractive index definition. So I can write it as a 1 minus N2 by N1. But N2 by N1 is equal to 1 minus delta. And now I know that what is the numerical aperture. So first of all, I will square it because I need it further. N2 square upon N1 square is the 1 minus delta whole square. The whole square will be 1 plus delta square minus 2 delta. Here delta is a very, very small quantity in compared to 1. So we will neglect it. So I can write it as a 1 minus delta because delta square will be neglected. This is neglected quantity. Now further we know that numerical aperture formula is N1 square minus N2 square. Take common as a N1. It is equal to 1 minus N2 square upon N1 square. This is numerical aperture. So N1, now put the value of N2 square upon N1 square. It is a 1 minus 2 delta. Solve it. Numerical aperture is N1. This will be cancelled out and it become 2 delta. So numerical aperture is this is the third formula for the numerical aperture, and the numerical aperture is the N1, the refractive index of the core, square root of 2 delta. Delta is the relative refractive index and it is an N1 minus N2 upon N1. So relative refractive index and numerical aperture, the final relation is numerical aperture as a N1 to delta. This is our result. Now we will define the V number. V number is also a unitless quantity and it is a number which define how many modes supported by an optical fiber. In an optical fiber, we can send a single information. In an optical fiber, we can send a multiple information. This is the optical fiber. It's depend on the many factor that it is a only single information which we can, it is a propagate inside the optical fiber, but it can be the multiple information can also be carried out. So V number define that this optical fiber is single moded or multi-moded. So V number formula, we will use it directly. It is a 2 pi a upon lambda into N1 square minus N2 square. So V is equal to 2 pi a upon lambda. We know that N1 square minus N2 square root of this quantity is defined as numerical aperture. So 2 pi a upon lambda is equal to, it is a numerical aperture. A is the radius of the core. A is the radius of the core. And lambda is the wavelength of the signal, wavelength of the light signal. So if value of the V number is equal to and less than 2.405, then it will be single moded. It will be single moded. Single moded fiber. Means if we calculate this value and we got 2.405 or less than this, then only one mode is supported by the optical fiber. If V is greater than to the 2.405, it supported the multi-mode fiber. It is a multi-mode fiber. It can be 2, 4, 8, 1000. It is a multi-mode fiber. So how many modes are propagated? It is a further number of modes can be calculated as V square by 2 for the step index fiber and V square by 4 for the graded index fiber. Number of modes we can calculate from here. So further, the time for the some numerical problem. Calculate the relative refractive index of the core and cladding by the following data. As we know that the Na is given and the delta is given. These quantities are given. So we know that the numerical aperture with the delta relation, I already did it. It is a N1 to delta. So N1 numerical aperture is given 0.2425. N1 and 2 delta 2.0135. So what is the N1? I will calculate N1 and got N1 as the 1.476. It is simply a number. Now numerical aperture is N1 square minus N2 square. So put the value of numerical aperture 0.2425. N1 1.476 whole square minus N2 square. So N2 after calculation it is a 1.456. N1 is 1.476 and N2 is 1.456. Now the second question. An optical fiber has the following data. The refractive index is N1 is given, delta is given. It is a given quantity. We know the relation between these quantity. Numerical aperture is the N1 to delta. Numerical aperture can be calculated as N1. It is a direct formula. 1.36 multiplied by 2 into 0.025. So after calculating it, 1.36 multiplied by 0.050. Calculation with the calculator got numerical aperture as the 0.304. There is no unit of the numerical. It is only light gathering capacity. It is a 0.304 at the scale of 1. So now the numerical aperture. Now the next we should find the acceptance angle. Numerical aperture is the sign of maximum acceptance angle. So, maximum incident angle. Numerical aperture is 0.304 sine of alpha max. So alpha max is equal to sine inverse 0.304. Sine inverse, it is a 17.7 degree. This is the maximum acceptance angle. Now the third formula. Compute the maximum value of delta and N2 and calculate the acceptance angle. This should be calculated. Given our core refractive index is given, diameter is 10, so A is the radius, is the 10 micrometer. So what is the V number? The fiber is coupled to a light source with a wavelength 1.3 micrometer. V cutoff for the single mode propagation is 2.405. We know the formula for the V number, 2 pi A upon lambda into numerical aperture. V is 2.405. 2 pi. Pi is the 3.14. A is the radius. So it will be, it is a diameter is the 10 micrometer. So radius will be 5 micrometer. And the wavelength is 1.3 micrometer. No need to change the unit of radius and wavelength because both are in the same unit, micrometer. And further numerical aperture. Numerical aperture is put here. So find the numerical aperture. Numerical aperture, after finding it, numerical aperture is 0.09957. After calculating it, numerical aperture is 0.0097. Okay, first numerical aperture is done. Second, We know the formula for the numerical aperture is n1 2 delta. And the value of the numerical aperture is 0.09957. 0.57. N1 is 1.5. So we will calculate relative refractive index. After calculating the relative refractive index, we got 0.0022. This is a very small quantity. I already told you it is a ratio of difference in the core and cladding refractive index to the core refractive index. It is a very small quantity. Third thing which we have calculated is the N2 and alpha max. So what is the N2? So N2 square minus N1 square is equal to numerical aperture. Numerical aperture is the 0.09957. And N2 we should calculate. N1 is 1.5 whole square. So we will calculate N2 from here. After calculating, we get the answer 1.497. This is our N2. Okay. And finally, we will calculate the alpha max, which is the sine inverse of 0.09957. So after calculating it, you will get the answer of all the quantities. The textbook which I refer is the textbook by the Brijlal and Subramaniam and the optics by Ajoy Ghatak. Thank you so much.